This video is on chapter 10, atmospheric circulation and weather systems. So in the previous chapter, we have read about how temperature is distributed over the surface of Earth. We have also seen that not every place on Earth has the same temperature and what are the causes behind it. Then we have also read about what causes low pressure and high pressure system. Then how winds move from one place to another, what happens when warm air interacts with cool air, and how heat and moisture is distributed across the planet, which helps in maintaining the Earth's temperature. So we have read about all these stuffs in the previous chapter. Now this chapter, on the other hand, deals with a little advanced version of the previous one, wherein we may encounter some technical aspects of wind pattern, weather system, and atmospheric circulation. So overall, it will be an insightful chapter with a slight bend towards technical aspects of some natural phenomena. Alright, then let's begin with the first topic, atmospheric pressure. So let me first tell you the meaning of the word atmospheric pressure with an illustration. It is the pressure exerted by the weight of the atmosphere, and atmosphere consists of gases, water vapor, dust particles, etc. So in simple terms, the atmosphere that surrounds the planet Earth, it exerts some pressure on the Earth. Now the question would be, why does the atmosphere exerts pressure? Well, you see, we all know that everything around us is made up of tiny particles called molecules, right? Even our own body is made up of tiny molecules that we cannot see. And in a solid object, these molecules are tightly packed and closely bound to each other. That's how it maintains the solid shape. Whereas in a liquid, it is a little more free. You know, the molecules are not very tightly packed. And in the case of gas, it moves around freely like anything. They are not bound to each other at all. They are free to move here and there. Now in an atmosphere, there are a lot of gases, right? So the gas molecules move around freely, and while moving here and there, they often bump into objects like one molecule with another, then rocks, trees, then our bodies. Now these molecules, when they hit all these objects, it creates a pressure, and this pressure is not happening from just one direction. It's in omnidirectional, meaning that it is not only exerted from above, but also from down, from side, from every direction at once. Okay, so this is what is atmospheric pressure. And always remember, pressure decreases with height or altitude. And we also know that as we go higher, temperature also decreases. That means we can also say that as the temperature decreases, the pressure also decreases. Now an easy way to understand this is you take a utensil, you put water in it, and you start boiling it. And it takes 100 degrees Celsius to boil the water. The moment the temperature is 100 degrees Celsius, you will see water molecules will start moving rapidly. And it is because of the increase in temperature this thing is happening. That means increase in temperature leads to rapid movement of molecules. And if the temperature is low, then there will be hardly any movement. I hope now you understand how atmospheric pressure works. Just to reinforce these 2 points before we go to the next topic, what we have seen is that with height, pressure decreases, and we have also seen that temperature, if it increases or decreases, pressure also increases and decreases, directly proportional. Just remember these points, okay? Alright, now let's get to know about vertical variation of pressure. So when we hear this term vertical variation of pressure, with the word vertical in it, you can easily figure out that we are talking about the variation of pressure while going up. As you can see, it's written over here that in the lower atmosphere, the pressure decreases rapidly with height. When we talk about lower atmosphere, we are referring to the troposphere. I hope you remember that figure which shows the different layers of atmosphere as we go from inside to outside. And I also hope you remember that the length of troposphere is somewhere around 10 kilometers from the surface of Earth. And then if you remember, the top of the troposphere is quite cold, and that's why nearly all of the water vapor, clouds and dust particles in the atmosphere are found in the troposphere. And now when you look at this table 10.1, here you see that on the left side you have the column where it shows from sea level, that is the ground level. It goes up to 10 kilometer, that is the end of troposphere. And next to it is the column with pressure. And again next to it you see the column which represents temperature. And it clearly tells you that as the temperature increases, the pressure increases. When the temperature decreases, the pressure also decreases. After vertical variation of pressure, it's time to get to know about horizontal distribution of pressure. So by the word horizontal, you can figure out that it's talking about the sideways movement of air. Now we know that wind moves horizontally, and while they move horizontally, they have speed and they do exert pressure. And this is what is known as horizontal distribution of pressure. So to understand the horizontal distribution of pressure, we do that by drawing isobars. So isobars are basically lines connecting places having equal atmospheric pressure. Iso means equal and bar is the unit of measurement for pressure. And if you remember in the previous chapter, we read about isotherms. They are lines joining places having equal temperature. So remember these two terms, isotherms and isobars. And always remember this point. Isobars play a major role in determining the speed and direction of wind. So the way we read air pressure on a surface is by looking at the patterns of isobars. Whenever you see these circles and the corresponding number, for example, here it says 1014 MB low. That means it is the lowest pressure zone of that region, okay? And then you see 1020 MB high. That means this enclosed region is the region with high pressure zone. So in between these two regions, you can see the speed of wind and direction of wind. That is how the MB is increasing and decreasing depending on high pressure to low pressure, because air always moves from high pressure to low pressure system. So MB is the unit for measuring pressure. MB stands for millibar, and we measure pressure with the help of an instrument called barometer. Let's go to the next topic, world distribution of sea level pressure. So when you hear the word sea level, I'll just show it to you with an illustration. So sea level means the level of the sea surface. It is used in figuring out the height of geographical features such as hills and mountains, and it is used as a universal standard. So basically we use the sea level as a standard scale to determine the height of various physiographical structures. Now going forward, we are going to read about equatorial low, subtropical high and subpolar low. So these are all high pressure and low pressure belts that are located on the Earth's surface at various latitudes. Now instead of covering these topics in this video, I've made a separate video on it. I'll put the link of that video in the description. Just go there and check it out, because this topic needs a nice elaborate video. That's the reason I made a separate video on it. So I'll link it in the description. Just go and check it out. Alright, let's move on to the next topic. Forces affecting the velocity and direction of wind. We all know that air moves in two directions, that is vertical and horizontal. The vertical movement is due to warming of air, which is called convection, and the horizontal movement is due to the differences of atmospheric pressure. Now let's quickly summarize the forces that are responsible for the horizontal movement of wind. The first one is pressure gradient force, which is the force that moves wind from high pressure to low pressure zone. Now gradient means slope, so the pressure gradient is strong where the isobars are close to each other, and it is weak where the isobars are apart. The second one is frictional force, which means the closer the wind is to the Earth's surface, gravity will have tremendous influence on the speed of the wind. That's why the wind in the upper atmosphere, that is 2 to 3 kilometers above the surface, are free from frictional effect, and winds over the oceans have minimal friction. The third one is Coriolis force. I've covered this topic in the video which moments back I told you to watch it in a separate link. So again, go there and refer to it. I have explained there very nicely. So in a nutshell, it is the force generated due to rotation of Earth in its own axis. We know that Earth rotates from west to east. Always remember that winds don't travel in straight lines. The actual path of wind is in circular motion. And we also know that winds blow from high pressure zone to low pressure zone. It is the Coriolis effect that makes the winds move in circular motion. Always remember this point. Wind in low pressure zone rotate anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Similarly, winds in high pressure zone rotate clockwise in northern hemisphere and anti-clockwise in southern hemisphere. At the equator, the forces cancel out each other. That's why the direction of rotation changes between the two hemispheres. Please don't forget to watch the video. I put the link of the video in the description as well as on the top right corner as a ticker. Please do check it out. Now we will get to know about the general circulation of the atmosphere. Before I explain the general circulation of the atmosphere, here are some of the important factors that influences atmospheric circulation. You will notice that some of these factors are the same that we went through in the previous topic. Alright, the first one is latitudinal variation of atmospheric heating. So what does it mean? As we go away from the equator towards the poles, temperature drops. And we know that. And that has a lot to do with the creation of warm air and cool air, which in turn has a greater influence on wind's movement. The second one is emergence of pressure belts. By pressure belts, we mean low pressure and high pressure belts. So you see these high pressure and low pressure zones are strategically located on the Earth's surface. It goes something like this. At the equator, it's warm, so we have low pressure. After that, in the subtropical region, we have high pressure, which is called subtropical highs. And then as we go near to the subpolar region, there we have low pressure belt. And finally in the polar region, it's high pressure. So like this, we have the pressure belts that are positioned strategically all over the Earth's surface, which plays an important role in the movement of wind. The third one is migration of belts following apparent path of the sun. Now pressure belts, that is the high pressure and low pressure zones, they change with the position of Earth while revolving around the sun. For example, during the month of January, it is winter in the northern hemisphere. At this time, many regions in the northern hemisphere witnesses high pressure zone. Likewise, in the month of July, when it is summer in the northern hemisphere, low pressure zone builds up in many places. So you see these pressure belts migrate with Earth's position. And while facing the sun and when pressure belts migrate, it does affect wind's movement. After all, sun is the ultimate source of energy. The fourth one is distribution of continents and oceans. So oceans play a fundamental role in shaping the climate zone that we see on land. Even areas hundreds of miles away from the coastline are still largely influenced by the global ocean system. Land is opaque and absorbs sunlight and gets heated up very quickly compared to the oceans. On the other hand, ocean is translucent. Therefore, it takes time to heat, but water loses heat slowly compared to land. Now, if you look at the tropical region, that is the water around the equator, there the ocean gets heated massively, and from there the heat is distributed all around the globe, both in the form of evaporation, that is when warm air goes up in the atmosphere and moves towards the pole. That's how water vapor humidity builds up in the atmosphere, and also the fact that warm ocean currents move towards the nearby land masses, thereby affecting the regional temperature and weather pattern. The fifth one is rotation of Earth. Now, rotation of Earth should immediately remind you of Coriolis force. As we have read about this, and I've also asked you to watch a separate video on it, so please I urge you to watch that video. The link is there in the description.